Bismillahirrahmanirrahim. Welcome to Glenrich Maths. Today we are going to solve a question which is based on finding the area of the shaded region. And that particular question belongs to paper 0606/12, means additional mathematics, for the session October November 2024. Let's see the question. We are going to solve question number 9, and the question says the diagram shows part of the curve y equal to 4 over 2x plus 1 and the straight line of 2y is equal to 6x plus 1. Find the area of the shaded region, giving your answer in the form of ln a plus b, where a is an integer and b is a rational number. I have already written the solution. Now I am going to explain in brief how I did the solution. So the first step, if we find more than one curves or more than one straight lines or curved and straight lines, then first step is we will have to find out the coordinates of the intersecting points, and we have supposed this point is as a. You can see here, this is, I have marked this as a point a. Then here also there is another intersecting point which has been, I have termed here as b. This point is b, and this is origin. Look, as this is written 0, so this is origin. And here there is d, another intersecting point. The intersecting point of the curve as well as straight line is c. Then we can draw a line between, we can join c and d, okay, so that this becomes a regular figure. So what is the first step? First of all, we will have to find all of the intersecting points. Let's start our solution. Let us write the equation of the straight line in y equal to mx from, or let us isolate y on the left side. So equation of the straight line is, we can see this is the straight line BC. Look, then the straight line, the equation of BC is this: 2y is equal to 6x plus 1. If we isolate y, what will happen? Or we can write hence y equal to, if 2 is transposed to the other side, it is going to be 6x plus 1 over 2. Just the same thing I have written over here. So y is equal to 6x plus 1 over 2. So this is our one of the equation. You can term as equation 1. Well, then we can see from the figure that this curved line AC, suppose AC is our curved line and BC is the straight line, they are intersecting. Both the curves of both the lines are intersecting at C. As they are intersecting each other, so definitely this C will be at this point, both of them will have the same coordinates. That means y equal to this as well as y equal to the equation of AC and BC must be equal. So this is the point to be noted. Whenever the lines intersect each other, then at that intersecting point, both of them will have same coordinates, means they will be equal to each other. That is what I have written. Let's see what is it written. Since the curve and the straight line intersect each other, these two equations will be equal. This is the equation of the straight line and this is the equation of the curve. Okay, so they must be equal. If we can write in this stage they are equal, then let us do cross multiplication. If we do cross multiplication, what will we get? We will get 6x into 2x, means 12x square. Then 6x plus 1 means 6x, and then 1 into 2x, that is 2x. After that, it is going to be 1 into 1 equal to it may be shown 6x into 2x, so 12x square. Then 6x into 1 means 6x. If we multiply by 1, then plus 2x plus 1 is equal to 8. 4 2s are 8. So this is simple cross multiplication. So after cross multiplication, we have got 12x square plus 6x plus 2x plus 1 is equal to 8. I have written the same expression over here. Okay, 12x square, you can see here, 12x square plus 6x plus 2x plus 1 is equal to 8. Let us solve this equation. This is actually it was simultaneous equation because both the curves, both the lines intersect each other. So this is simultaneous equation and we are solving simultaneously. Well, so 6x plus 2x is equal to 8x. So 12x square plus 8x minus 7. Now we know how to factorize this. 7 12s are 84 and 14 6s are also 84. So we can write in this way, and as this is the symbol is negative, so we have done subtraction. From 14, if we subtract 6, it's actually 8x, positive 8x. Well, then from this, from each of the pair, we can get something common. In this pair, 2x is common. If we take 2x common, there remains 6x plus 7. From the next pair, if we take negative 1 common, then there remains 6x plus 7. That means we have got two factors. As the curve is, quadratic, then there are two factors. One factor is 6x plus 7, another one is 2x minus 1. So 6x plus 1 and 6x plus not 1, 6x plus 7, sorry, it should be 7. 6x plus 7 and another one is 2x minus 1. Okay, these are the two factors we have got. Now we are going to find the roots. Let's see 6x plus 7. Okay, if we take this one, how we can reject this 6x? Suppose if we talk about this 6x plus 7 is equal to 0, whether it is possible or not. Let's say that means our x is going to be negative 7 over 6, means the value of x is negative, the root is negative. Now let's verify whether this is possible or not, whether we get negative value or not from the graph. Look at this, we are talking about c. Okay, here this intersection, we are solving the equation simultaneously for this point. Now can this point lie, for negative value, the values of x will lie on the left side of origin or 0, but does our c lie on the left side? Not at all. Our c is on the right side, on the right side of o, so no way it can be negative. That's why we cannot accept the negative coordinate of x. Once again I am telling, we are actually solving both of these equations as well as this equation simultaneously for finding the intersecting point, and intersecting point c is lying on the right side of our origin, which is definitely positive. X coordinate can never be negative, neither y coordinate, because above, this is above x-axis. So for negative value, actually x or x should lie on the left side, where we can see that our c is lying on the right side of origin. So c must satisfy the positive value of x, positive root of x. So that's why we have just rejected this one, as this produces negative value. We have rejected this. I think you have understood. So as we cannot accept this factor, so this is the factor to be accepted. And here, as explanation, I have written here x is greater than 0, because our coordinate, we are searching for a coordinate which is lying on the right side, greater than 0. So 2x minus 1, this is the factor we have taken. So from this factor, x is equal to half. We have got that our x coordinate is half. Okay. Now we will see, let me erase this overwritten part. Well, then we have got the x coordinate. Okay, x coordinate is half. Now we will come to know what is the corresponding value of y. Look at this. Here x is half. Okay, at c x coordinate is half. X coordinate is half. Now we should know how much is the y coordinate. It can easily be found if we this is our any of the equation. There are two equations. Okay, there are two equations and both of the equations are intersecting or meeting at the same point, isn't it? As they are meeting at the same point, so at in any equation, if we substitute the x coordinate, we will get the y coordinate. So we have chosen the first equation. Then if it is written here, x is equal to half, x equal to half, this is our equation. We have written here x equal to half when y equal to what was our equation? Our equation was 6x plus 1 over 2. Okay, this is our equation of the straight line. I'm repeating again, you can substitute the coordinate x coordinate in any of the equations because we have solved the equation simultaneously. So in any equation, the corresponding value of y will be same. We have chosen one of them, which is 6x plus 1. Let me show you again. It was 6x plus 1. Look here, the equation of the straight line. Equation of the straight line is 6x plus 1. So x, already we have obtained our x coordinate is how much? X coordinate is half. So 6 into half plus 1. What is it going to be? If we dissolve this 2 by this 6 by 2, so this is going to be 3. So 3 plus 1 equal to 4 and denominator is 2. So 4 over 2 means it is 2. So our y coordinate is 2. Our x coordinate was half. Let me erase this. X coordinate was half, whereas our y coordinate is 2. So these two are the coordinates of C. We have written here coordinates of C are half comma 2. We can write this value over there, half and 2. We have got that the coordinates of C are half and 2. So this is half, C coordinates of C half and 2. Okay, this is our coordinates of C. Now we will find the coordinates of B as well. That's why I have written over here the straight line intersects y-axis where x is equal to 0. Means if we look at the figure, look, this is the straight line BC. BC is the straight line. Look, this is our BC. Okay, this is BC. BC is the straight line which is meeting this y-axis. Look at this y-axis. AB is the y-axis. So at y-axis it is meeting at B. Now at anywhere on this axis, the coordinate of x is 0. X coordinate is 0 here. So if x coordinate is 0, we can find the corresponding y coordinates. So once again I am telling that on this y-axis, this is our y-axis. On y-axis, all the values of x coordinate is 0. If x coordinate is 0, we can easily find y coordinates. The same concept I have written over here. It is the straight line intersects the y-axis where x is equal to 0. So y-axis means any of the x coordinate will be 0. So if x is 0, then we will have to find how much is the y coordinate. We have written here x equal to 0 when y is equal to 6. Our equation was, what was our equation? Equation was 6x plus 1 over 2. So if x is 0, so 6 into 0 plus 1 over 2 means 6 zeros are 0, there remains half. So at our coordinates of B, this is our coordinates of B, when x is 0, y is half. We can write over here our this point. Here x is 0. X is, we know, 0 and y coordinate we have got is half. So here 0, half. We have got two coordinates or intersecting points, then we will find out area under the curve. As we have got all of the intersecting points, the required intersecting points have already been obtained. Now we can easily find the area under the curve. Let us see the curve. So this is the curve. Curve is, look at this AC. AC is, the A is over here and C is over here. So we will see the area which is covered by the curved line AC. So for finding area under a curved line is actually integration. So we have written here the integrand of AC, and the equation, let me show you the equation of AC is this. This is the equation of AC. So we will just integrate the equation of AC because we have got all of the intersecting points. Now at this point, a question may arise in your mind that we have obtained the coordinates of B as well as C, then why didn't we find the coordinates of A? At A, look at this, A is the point which lies on y-axis, okay, on y-axis. So at y-axis, we know one of the coordinates x is 0. Here x is 0. Then what is the other coordinate? I mean y coordinates. Actually, we don't need this y coordinate at all, because whenever we find the area under a curve, then we require the limits. So limits of x with respect to x, we integrate. That's why the lower limit and upper limit. In this case, if we talk about this curve, look at this. The curve, we are going to calculate only this portion. This is our limit. So here x is 0 and upper limit of x is what? Half. Look at this. Here x is 0 and upper limit is half, and y is not necessary for us. That's why we are leaving at this stage. We require this portion, only this portion. Okay, they have told us to find the area of the shaded region. So shaded region belongs from starting from here to here. Okay, so our limit is from 0 to 0 until half. That's why here finding y coordinate is unnecessary at point A. So what have we got? Our limit, lower limit of x, lower value of x is 0 and upper limit of x is half for the shaded region. So we have written here, let's see our steps of solution. Here it is written area under the curve is, area under the curve is, that is from 0 until half. I have already told. This is our y function. Our function of the curve was what? 4 over twice x plus 1. Okay, I have written here y is equal to this. This was the function of the curve. So we have written 0 until half. Once again I am telling that 0 is the lower limit from the graph and half is the upper limit. Once again let me show you from the graph our lower limit of x. Look, starting from x, this is our x from this point until this point. Okay, this should be obtained. That's why we have used lower limit 0 and upper limit is half. So 0 until half, we are going to integrate this, means to find area of any curved line under any curved line is actually integration. Okay, if we integrate this can be written, look at this 4, there was 4 over here. Okay, this 4 has been written in split form, that is 2 and 2, 2 2s are 4. Now the question is, why have we undergoing this, why are we undergoing this complication that 4 has been split into 2 into 2? Let me see that antiderivative is, actually integration is antiderivative. Derivative of, we will find the derivative of this. Integration of 2 over 2x plus 1. 2 over 2x plus 1 is actually ln 2x plus 1. And if I explain the shortcut method to remember is this, we know that integration is actually antiderivative. Integrand is always antiderivative. That means reversal of differentiation. So let's differentiate this. If it is ln twice x plus 1, okay, if we find derivative of this, what will it be? Let's see. it will be actually derivative. The formula for ln function is ln function, the function remains the denominator. The function remains as denominator, there is no change. And in numerator, just avoiding ln, we just find the derivative of the function. So what will be the derivative of the function? Derivative of 2x is 2 and derivative of 1 is 0. So it is actually 2. So derivative of the function, inner function 2x plus 1 is actually 2 and the denominator remains unchanged. So through elaboration I can write it. Let me erase this. If I write using formula, then it is going to be the derivative of d over dx of this, the function. Okay, this is the way to integrate to find the derivative of ln function, and then the function, then the function. So the function is ultimately, what is it going to be? Twice x plus 1, and derivative of 2x is actually 2 and derivative of 1 is 0. So ultimately what have we got? That the derivative of that means ln 2x, derivative of ln 2x is 2 over 2x plus 1. So if this is derivative of ln 2x plus 1, so integrand is just opposite to this. What will it be? It, if it goes back to this, so 2 over 2x plus 1 is equal to ln into 2x plus 1. That means the derivative is opposite to integrand, and integrand is also antiderivative opposite to derivative. So I think you have understood that ln function, if we want to if we want to find the derivative of ln function, that is the function remains as it is unchanged and the numerator is the derivative of that inner function. Ln goes away. Ln goes away in case of differentiation, as ln 2x plus 1 produces 2 over 2x plus 1. So integrand of this one will also be the ln function 2x plus 1. I think you have understood. So what have we learned from this point? That integrand is actually antiderivative opposite to differentiation. So the, if we differentiate ln 2x plus 1, it just goes back this function. If we just differentiate this to ln 2x plus 1, it will be just this. So this is reversal way we have done. This is the shortcut method. Whenever we just differentiate, we integrate any function, then we will try to go back to the derivative. So derivative of ln 2x plus 1 is actually 2 over 2x plus 1, as I have told. Once again, for the last time I am telling, if we let me explain again. Let us find derivative of, once again I am writing, please don't be impatient because there is a crucial point lying here. Derivative of d over dx of what? Ln 2x plus 1, ln 2x plus 1. If we find the derivative of this, the same function, the function remains as it is as denominator, and the numerator is the derivative of the inner function. So derivative of the inner function is actually 2. It is 2, nothing but 2, because derivative of 1 is 0. So ultimately it becomes derivative of ln 2x plus 1 is 2 over 2x plus 1, and integration is just antiderivative. So it is dy over dx of ln is equal to this, and then if we just go back, if we just write over here the integrand symbol, then it will also go back. They are just opposite to each other. Okay, this one, derivative of this is this, and integrand of this is that. That's why we have written that 2 over 2x plus 1 is equal to integrand of that is ln 2x plus 1. Let's see the next step. The next step is, our limit is what? From 0 to 2. If we substitute to upper value first, upper limit is 2. So 2 into 2 means 4. Okay. not 4. Our upper limit is half. So if we write here 2 into half, 2 into half plus 1, what is it going to be? It is going to be 2. That's why we have written here ln 2, and the lower limit is 0. If we write here 0, 2 into 0 plus 1, it is going to be 1. Okay, so upper value is 2 and lower limit is lower value is 1. So ln 2 minus ln 1, and we know ln 1 is equal to actually 0. Ln 1 means 0. So ultimately we are getting 2 ln 2. This is the area under the curve. Now we will have to find the area under the straight line. Okay, area under, we have got, let us go back. We have got the area under the curve. Now we will find the area under the straight line. Okay, this is the straight line. From this we'll find how much is the area occupied under this. Okay, so then we have written here area under the straight line, area under the straight line. And if we look it carefully, we'll find what this is. Look at this, BC, our, this straight line is covering BC, CD as well as OD and OB. Okay, so this is actually a trapezium. This is a trapezium. So what is the formula for trapezium? Area of trapezium is half into this two, sum of this OB and OD, half into OB plus OD. Okay, half into OB plus OD into the distance between these two. Okay, distance between OD, because this is the perpendicular distance. So how much is the OD? You know, the coordinates of D is, for x we have already obtained its C coordinates. X coordinates of C and D are same, so it is half. It is actually half. And y coordinate is definitely 0, isn't it? Now if we talk about how much is the distance from O to D, it's very simple. This is half, because x coordinate is half at D as well as at C. That means from O to D, the distance is half. That's why it will be OB is for OB, if we talk about this distance, means this way. Okay, OB is also half. From O to B is half, from O to D is also half. It may sound weird that how can these two distance be equal, whereas it is apparent that they are longer than the other. Actually in x coordinate the unit was different, whereas in y coordinate also, in x-axis, that means direction along with the x-axis was different unit, was of different unit, whereas the upper or vertical direction, the unit was different. So we don't bother about that. We just find whether this is mathematical or not, logical or not. So O to D, once again I'm telling, O to D our distance is half in x direction, and O to B the direction is also half, that is for vertical direction. So O to B, OB is how much we have got? This is half and plus OD. OD is what? OD is also half. Then the distance between OB plus OD, sorry, OB plus CD. It is not OB. OB plus these two sides for travel, it is CD, not OD. CD is what? C to D. Look, C to D is actually here, the coordinate is 2. That means this length, this magnitude is also 2. So it will be actually 2. Half plus 2. Let us write here half plus 2. Half plus 2 into that is OD. Okay, OD we have already explained that OD is also half. Okay, so this is actually half plus 2 into half. The same thing, once again I am explaining that from O to D the distance is half. Then C to D also distance is 2. C to D distance is 2, and O to B also distance is half. These three dimensions or magnitudes are required for finding area under the straight lines. So we have written the same fact over here. Our distance is half into OD into OB plus CD. Our trapezium is actually OBCD. This is our trapezium. So area of this trapezium is half of OD into OB plus CD, and OD is half. I have already explained. OD is half and OB is also half. OD and OB are of same length, and CD was 2. Then if we simplify this, half into half, 1 over 4, and half plus 2, this is actually 5 over 2. Means ultimately we have got that 5 over 8 is our area under the straight line. So we have got two area. Look at this. One area was area under the straight line, under the curve. Area under the curve is this. Area under the curve was, how much was the area under the curve? This was the area under the curve, and area under the straight line is this. This is the area under the straight line. So if we subtract, if we look carefully at the figure, we will see, let me erase the everything from here because it looks very messy. Finally, we are going to find the area of the shaded region. So how can we find the area of the shaded region? We have found area under AC, the curve, this one. Okay, we have got the area, full of this area. Full of this area has been obtained. Okay, we have got the area under AC is this. Now from this portion, if we subtract, this portion, this, look at this, this is the our trapezium. So if we subtract this, we will get the our shaded region, isn't it? So what have we done? From whole of the area, of this, it will look like this. Okay, this one. So from this, if we subtract this portion, is subtracted, I mean this portion, sorry, red portion. If red portion is subtracted from whole of this, we will find the area of the shaded region. This is our area of the shaded region. Let me show you again. This is the shaded part. This is the shaded part. So for shaded part, what are we going to do? The whole, from whole of this, we are subtracting the area of the lower portion under the straight line. So simply we have written this here. Let us see area under the in the next page. I think it's written page number 3. Okay, so we have written here, already I have explained that area under the area of the shaded region is area under the curved line minus area under the straight line, and area under the curved line was 2 ln 2, and area under the straight line was 5 minus 8. Okay, let me show you for confirmation again. Area under, look at this, area under the curved line was this. This was the area under the curved line, and this was the area under the straight line. So if we subtract the area under the straight line from area under the curve, we will get our desired area of the shaded region, as I have explained from the figure. And we cannot simplify it any longer. So this will be our answer. So what have we learned from this? This is the whole of the solution, and if I recap, I will tell you in short that first we have found all of the coordinates. All of the coordinates were here. This one coordinates, that means coordinates of A, coordinates of C. Coordinates of A is not necessary because already it is x. We know x coordinate is known to us, which is 0. And we have got the coordinates of C. We required the coordinates of D, and we got the coordinate of B, where x is known to us because on y-axis x is 0, and this is origin, we know 0 0. Then after that we have got the area under the curve. Area under the curve is actually the integration of the function. Then from that, this OBCD looks like a trapezium. Then we have got the area of a trapezium. Then we have subtracted that area of the trapezium from area under the curve line. Finally we got the area of the shaded region. Well, that's all from me, and I think you have understood better, at least through my effort. If it benefits you in the least bit, please pray to Almighty Allah for my improvement, for my betterment. That's all from me. Fi amanillah.